Suppose you walk 20 meters in one direction. I want to stop right here and draw a picture describing what we've just learned from this problem. This is generally the best way to solve physics problems because you write down the information as you read it and extract it. So let's say we start right here at this position, and then we walk 20 meters in one direction. That's what this path represents, and we can give it a label of 20 meters to represent the distance. Then you turn around and walk 5 meters. We can also draw this on our picture and add to it, showing that we went the other direction and walked an additional 5 meters. What is the total distance you've traveled? Distance is usually represented with the letter D, so we can write this down and then add up the total distance that we travel in this problem. So we first go 20 meters, and then we turn around and go another 5 meters. So the total distance traveled is 25 meters. Then it says, what is your total displacement from the starting point? Since displacement is a vector, we need to have a starting point, and so that's where we began. Displacement is written as delta x, which is math speak for a change in x. That is, some final position minus an initial position, because x represents position. On the graph, this is represented by a vector pointing from the initial position to the final position. xf is the final position from our starting point, and we know that it's 15, because 20 minus 5 is 15. xi, or the initial position, is equal to 0, because that's where we started. 15 minus 0 is just 15 itself, and so the total displacement is 15 meters. I want to draw another picture to drive this fact home that there is a significant difference between the total distance traveled and displacement. So my blue line represents the total distance traveled, because I went 20 meters and then I went back another 5. But the displacement in red only depends on the initial and final positions. Notice the problem says total displacement, but this is unnecessary and misleading, because displacement only depends on 2 points, not on the path traveled.